Once that's done, we will proceed to set up the actuators. Click on Speed Control under Electrical and set the previously defined rotational joint speed control to 0. We will create the signal later. Click OK. Next, in the electrical menu, click on the symbol table and then on the signal adapter below the drop-down arrow. We will first create the input signals. Which primarily control the forward and reverse rotation of the motor shaft. Select the speed control you just created. Click Add Parameter and check the necessary options. Since the motor has both forward and reverse operations, we need to set up two input signals to control the motor shaft's forward and reverse rotation. The speed data type is double integer, and the signal type is Boolean. So we will need to convert these two data types using formulas. Click on the speed parameter, then click Insert Conditional. When the forward signal is received, set the motor speed to 200. If the reverse signal is received, set it to -200, otherwise, it should be 0. Once the input signal setup is complete, click OK. These buttons will output signals to the PLC, so we need to create the output signals. Click on the electrical, then select Signal Adapter. We'll configure the displacement for these buttons. For example, pressing them down by 2 mm will trigger an output signal to the PLC. So we need to convert these signals. Select Mechatronic Object. Then click Add. Note that we are adding the sliding joints for each button. And change their names accordingly. We will turn these sliding joints into 4 output signals. Copy the details over. And ensure to check the boxes. Remember, the speed type and data type are different, so a formula conversion is necessary. When will the signal be activated? The output signal will be activated when the position of the sliding joint is greater than 2 mm, otherwise, it will be false. Use the same method to set up the other buttons. Check for any issues. and click OK. After completing the signal setup, we will move to PLC programming. Open TIA Portal, create a new project. And click on Project View. First, we need to perform a configuration by adding a new device. Since we're using PLC simultaneous for signal connections, select the S7-1500 PLC. After opening it, right-click on the PLC, go to Properties, and use the default Ethernet address. In the Access and Security section, ensure that the full access permission is checked. Then click OK. Before programming, let's add a variable table. It's best to name this variable table to match the names in the MCD, as we can directly export the signals from MCD. Click on the electrical, then select Export Signals, and choose the location to save the exported signals. Click OK. Open the exported signal table. It includes names, the corresponding adapter, data types, and current values for each I/O port. Here, the forward and reverse signals for the motor shaft are input signals, while the others are output signals. We only need to copy these names over to TIA Portal. In MCD, the forward and reverse motor signals are input signals, while the other signals are output signals. In the PLC, this is reversed, so for the PLC, the motor signals will use queue addresses for outputs. Since we are using a virtual simulator, we will not use I addresses. Instead, we will use M addresses for the input signals.